Okay, in this video we go over the economic order quantity model, the EOQ model. The EOQ falls under the umbrella of fixed ordering, and what that means is that we order the same amount every time we place an order. The time that we place the order may change. So the concept behind fixed ordering is that we're constantly monitoring our inventory, and when we hit a reorder point, we order the order quantity. So we're always watching our inventory levels, and then when they drop below a certain level, that triggers an order. And then what do we order? We order the optimal order quantity. That's what we're going to determine. So here's the example on page 541, solve problem 2. And what we have is that we have things that we purchase for 20 bucks. So that's a dollar amount. This is the unit cost. This is the annual demand. We expect to sell or use 1,000 a year. The cost, every time we pick up a phone and place an order or we order through some system, there is a cost to us. We either had to have the system in place or we're paying someone to do it. It's not really a function of how much we order. It's the act of ordering. So when you order something, they're going to ship you something. All these, we're going to say it's based on the act of ordering, and it costs us $5 every time that happens. The cost of carrying one unit for a year is 20% of the unit cost, so we can calculate that. So the annual cost of carrying something for the year, so if I had one item and I put up on a shelf, first of all, I've got to have the shelf to put it there. Then, so that means I've got to have the space. I've got dollars tied up in it that I can't use in something else. There's a chance it could get stolen, broken, it could go bad, obsolete. So all of these tell me that when I carry inventory, what it costs me at the end of the year using that shelf space for that is $4. So based on these cost drivers, this and this, as well as demand, the optimal order quantity in the book is the formula square root of 2 times D times S divided by H. Square root 2 times the annual demand times S divided by H. And this will give us This will give us the order quantity in units. So this says then I should order, every time I order, I need to place an order of 50. So I'm not going to order it all at once. I'm going to order 50 at a time. So if I order 50 at a time, that means when something shows up, I now have 50 more. So my average inventory level, if I order and time it where it shows up right before I run out, my average inventory level is going to be this divided by 2, or 25. So my cost then for the year of carrying on average 25 units is that 25 times $4. So it costs me to carry this order quantity for the year $100. Well, how many orders do I have per year? The number of orders I have per year is 1,000 demand, and I order 50 at a time. That's 20 orders I have every year, and it costs me $5 at every order. So my annual cost of ordering is this. And look what happens. When you use this formula to determine your order quantity, what it will always do is balance the cost of carrying against the cost of ordering. So these will be equal. So my total cost is that. Now that's not the cost of buying the product. That's just the cost of my inventory policy. Well, let's add some more information. Let's say that the lead time is 7 days. So when I place an order, 7 days later it shows up. And let's assume that we have 250 working days per year. Doesn't mean that all that means is that we're probably not working weekends and holidays. So I can determine what my daily demand is. It's my 1,000 divided by 250 days per year. So my daily demand is 4 units per day, 4 working days per year. That's the daily demand. So if I don't have any uncertainty, which we'll cover that in the next video, my reorder point is my lead time multiplied by my daily demand. And all that means is that I'm going to be monitoring my inventory, and when it hits 28, I place an order, I order 50, and then right before I run out, that 50 shows up. The time between orders is Q over D, 50 divided by demand. Now that's a time period in years. Well, I don't know what that means, so I can convert this into days by taking this number. This is in years. I can take this and convert it to days by taking this number and multiply by how many days per year I have. So roughly every 12 and a half, so every 2.5 weeks or so, I'm going to place an order. And I'm going to order this amount. But really, I'm not going to worry so much on this. I'm watching my inventory. This is just on average what happens. So let's look at some differences. Well, what if I don't want to order 100 at a time? 50 at a time. What if I want to order roughly monthly? So if I would take this number and divide by 12, what if I want to order 83? Well, what's that cost? So rather than, look what I'm going to do. I'm going to overwrite the formula. And when I order more than that, let's actually order quarterly. Let's order this divided by 4. Let's make it a little easier. So I want to order 4 times a year. So rather than ordering 50, I'm going to order 250. So my cost of ordering is going to go down drastically. So it's because this is only going to be 4 times a year. But my cost of carrying inventory is going to be higher because my inventory levels are going to be higher. I'm ordering in larger quantities. So if I overwrite this, look what happens to my numbers. 100, 100, 200 become 500 this. So I more than doubled. 2.5 times is what my new cost is because I've got a larger inventory. So that's no good. You don't want to do that. But what if we order very small? Let's just order a daily amount. Let's just order every day. So I'm going to order 4 a day because that's what my daily demand is. Let's order 4 a day. Well, you can see then that my inventory cost is going to be very, very small, but I'm going to be ordering all the time. Every time I place an order, it costs me $5. Well, that's even worse. So you can deviate slightly, but when you do these extreme deviations, you're going to see the consequence in the cost. Okay, thanks.